In our previous videos, we have learnt about why to represent knowledge, how to represent knowledge, what are the different approaches to represent knowledge. Okay, so all this we've seen in our previous video. Let us go to our next. Like, what are the issues with respect to knowledge representation? Okay, what are the problems? So first one is issues in the sense what we have to consider while knowledge representation. So first one is important attributes. Okay, so we need to understand and identify important attributes. Okay, so instance and either, these are the two important relations, right? We have seen they were marked over the arrows. So these also support the property inheritance. Okay, so what I want to say over here is instance and is a, right? This should be used. These are the two important attributes. Okay, so these two attributes along with them, few other important also should be identified and used properly. Okay, so in case of important attributes, you have to instance as well as is a. Second one is relationships among attributes. So what about the relationships between attributes? You have various relations as inverse, existence. Okay, techniques for reasoning about values, single valued attributes. Okay, I'll show you with the help of example. Band. Okay, what is it? Band, John, Secret City. So I want to say a sentence that my statement is John plays in a band called Sacred City. Okay, John plays in a band called Sacred City. So here I have given John, band, Sacred City. Okay, these are the values, John as well as Sacred Cities. Now this same statement can be said in this fashion also. John's band is Sacred City. Okay, so this says inverse relation among both, right? So this statement gives me, like, I can say that John plays in Sacred City, or second statement is John's band is Sacred City. John plays in band Sacred City, or John's band is Sacred City. So this is called as inverse relation. Okay, in this fashion we have to check what are the relationships between attributes. Okay, let us go to the third issue, choosing the granularity of representation. What do you mean by granularity? It is nothing but level. At what level should knowledge be represented? What are the primitives? What are the levels of knowledge representation? Okay, let us again see with the same with the help of an example. Okay, I have a statement, feeds Tom dog. So what is happening over here? Tom is feeding a dog. Okay, Tom is feeding a dog. Now I increase my level, okay, my granularity to the next level. I can, same statement, I write in little details as Tom gives dog bone as a food. Okay, so what it is, Tom gives dog bone. Okay, so the same we can represent as gives x comma food feeds x. That is someone that is Tom is given dog food. Okay, generally dog or anyone else food. Okay, it is feeding, in this fashion it is feeding the dog. Okay, so these are different levels of granularity. Okay, so sometimes I want my knowledge in details, sometimes I don't want in details. So that is called as how do I want, like here I'm just understanding that Tom is giving food to dog, and here I'm understanding what food it is giving to dog. Okay, so it's this is called as level of granularity. Okay, next example is John spotted Sue. Okay, so spotted John comma Sue, John has spotted Sue. Okay, so same I can say as spotted x comma y. Now why did I write this? Here granularity level is increased. Why? Can you answer my one question for this? If I don't have this, if I just have this, can you answer my question that did John see Sue? Did John see Sue? No. See, looked at Sue. That means, okay. So my question is, did John see Sue? You won't be able to answer. So here we have modified the granularity. What is our granularity? Spotted x comma y. Why? Okay, so y is spotted by x. For example, John spotted Sue. Okay, and conclusion is John has seen Sue. So since you is also there. So both the parts we can, like, you can answer this question like, did John sees you? Yes, it has since you. Okay. So here level of granularity is increased. Fine. So this was our third issue. Next issue is representing the set of object. Okay, how to represent the set of object. So in order to represent, we have logic. Remember? Okay, we will study further that is universal quantifiers, exponential quantifiers, universal quantifier for all. Okay, so that is used to represent the set of the object. Now the query is, how are you going to represent the set of object? If certain properties of the objects that are true as a member of a set but not as individual. Now sometimes what happens, if it is a part of a set, that particular property is true, but if it is used as an individual, that particular object is used as an individual, then that particular property is not true. If the property is true for almost all the elements of the set, then it's more efficient to associate that particular property with that set rather than associating it with every element. Means if there is certain property, okay, and that property is true for all the elements of the set, then instead of attaching that property with every element, we will directly attach it with whole set. Okay, so universal quantifier, the for all is used for it. Okay, inheritance propagates down to the individual. Now here one example is shown to you, large elephant. So what does it mean? It means that set of elephant is large, or it also means that anything that is elephant is large. So again, whatever granularity you want to take, because all the elephants are large, you can say that there is certain set of elephant and all that particular set is large, or I can say every single element of that particular set is large, because this property is true for set also and for all the elements of set. Okay, so this is nothing but representing the set of objects. You take a set, you find what property is true for all the elements of set, so you give that property, you assign that property to whole set rather than assigning it again and again to every element. Okay, and last one is what? Finding the right structure as needed. So you need to select the initial structure, then we need to revise our choices. Okay, so have to perform initial selection, have to fill appropriate details from current situations, have to find better structure, what to do if no structure is appropriate. These all questions are addressed later. Okay, so finding right structure is also needed, and all these questions depend upon what problem you are trying to solve. There's no specific strategy to these questions. Okay, so further we are studying knowledge structure hierarchy. Okay, we have knowledge structure. Okay, this is what the 5 things what you have studied. What all were there? First was attributes. Second one was what is the relation between what is the relation between them? How granularity is there at different levels? Okay, what object, regarding object, how to represent the set of object, and finding the right knowledge structure. Okay, so in this fashion all the 5 issues are related with each other. So if you can see this knowledge structure, I have connected using double arrow. Okay, in this fashion they are represented, like you have proper attributes. When you have proper attributes, when you have proper relations between them, when you are representing set of objects properly, you decide what is the level of granularity, means how deep do you want to represent it, and you require certain knowledge structure. Okay, so these all things we require when we do. Okay, so here we are seeing knowledge based agents. Okay, so what do you mean by KBA? So how to represent this knowledge? We require KBA. KBA stands for knowledge based agents. Okay, so what is this agent? Agent is the one who acts as per the environment. Okay, it does all the necessary actions depending upon the environment. We have certain agent. Okay, so now actually to act, it needs knowledge of how to act, but that agent should know the background, like what is the knowledge, so accordingly it can act. It is provided by knowledge base. Now whatever knowledge is needed by this agent is given by knowledge base to it. Okay, so what is knowledge base? Knowledge base represents the information that helps agents to act. So knowledge base contains knowledge, okay, in a proper format. So that knowledge is further needed by agent, so that agent can act properly. Okay, so I can say that actual facts that exist in the real world, okay, that is nothing but knowledge, and that knowledge is present in knowledge base. Now set of the sentences to describe the information related to world, that also you can call it as knowledge base. Okay, so now this knowledge base agent is there. Okay, right. this knowledge based agent takes the information from the environment by perceiving it. This knowledge based agent consists of two parts. Okay, one I call it as knowledge based agent consists of two parts. One is nothing but knowledge base, and second is nothing but inference system. So here we have knowledge base and here we have inference system. So as I said, what do you mean by knowledge base? It consists of all the knowledge, all the facts of the real world. Okay, so these facts are needed by agents. Okay, so I can say agents need knowledge from knowledge base. Okay, and this knowledge is represented in which format? It is represented in knowledge representation language. There's a special language. It is not English like sentences, but it uses KRL. Okay, that is knowledge representation language. And this KBA also contains inference system. Inference system is what? It gives conclusions. Okay, engine of knowledge based system which allows to infer new knowledge in the system. Means already 10 facts are there, and based on 10 facts I am giving the 11th fact. Okay, for example, if my two facts are it's getting very humid today and there are clouds in the sky. So based on this I can give that maybe it will rain today. Okay, so this is nothing but conclusion. Now the previous two were the facts which were the part of the knowledge base, and the third one is my inference. So I have given it as like English like sentence. It has to be there in KRL. Okay, we will see further. So here in the form of diagram it is shown. We are learning knowledge based agents. Okay, so what happens is this is nothing but KBA. This as a whole is nothing but KBA, and this is your environment. Okay, so we get the input from environment. Okay, so KBA takes input. Fine. So it takes knowledge base. So this is our knowledge base, and we have inference engine. So what we have to do is it has to perform learning. Okay, it has to do learning from what? KBA. As I said, those two statements are over here, and my third statement will be concluded by this inference engine, and that will be given to as an output. Now first only, what was my statement? Like it's very humid today. Okay, so the sensing, like sensors are there, and from the sensors, like from environment I have got the input, like it's very humid today, and secondly I said that clouds are there in the sky. So thirdly, conclusion is made by this particular system that it is going to rain today. Okay, so in this fashion it works with each other. So you can see that it takes input from environment and perceives it by perceiving it. Okay, inference engine takes the input, and this inference, like initially you can see this inference engine is taking the input, and this input is given to knowledge base, and knowledge base is already having some previous facts, plus it has got certain new knowledge. Okay, previous facts, new knowledge, it is combining all together, and it generates a conclusion, and further conclusion is given as an output. Okay, so this knowledge base is collection of sentences. It is the central component of KBA. It's the most important part of KBA. Okay, and mind well, English sentences are not there. We have to learn KRL, knowledge representation language is used over here, which depends upon logic, predicate logic. Okay, so here you can see the mechanism of agent program. What does it tell? It tells what have I perceived. Okay, it asks what action should I take, and it tells chosen an action and executed it. Okay, so as you can see in the diagram, knowledge base agent tells knowledge base what have I perceived, like what did it perceive from environment. Okay, it asks further, it asks to the knowledge base that what action I should take. Whom is it asking? It is asking to knowledge base. Okay, so knowledge base is so important, and further it tells, the agent tells knowledge base that it has chosen an action and executed. Okay, so everything depends upon knowledge base and knowledge agent. So here functions are written with respect to it. Okay, so the first function is make percept sentence, make action query, and make action sentence. Like three things were there, right? It is telling, it is asking, and it is telling. Okay, so in order to tell what have I perceived, the function is make percept sentence. It makes percept sentence. Then for second function, it does make action query, like what action should I do. Okay, so because this is query. Okay, and thirdly it tells it that what actions I have taken. So it is again a sentence with respect to action. In this fashion we have three functions. So the first one is make percept sentence. This function returns a sentence which tells the perceived information in perceived information by the agent at a given time. Okay, so whatever I have perceived. Okay, so for that I have the like whatever agent has to tell it to the knowledge base. So for that you have your first sentence, make percept sentence. Secondly, it has to ask knowledge base that what action I should take. So this function returns a sentence which, like query sentence, which tells what action the agent must take at the current time. And third sentence is it is again a sentence where it says that whatever action it has taken, it has already executed. Okay, that. So these are the three functions. Okay, so next levels of knowledge base agent we will be seeing in our next video. Thank you.